Okay, now, here's the thing with your applications. Anytime it uses the word maximum or minimum, that's what we're going to put in your y equal. Anytime it has a maximum or minimum. Because what's going to happen is you're going to get a parabola. If it's a maximum, which way is it going to open?
Down.
Down. Here's a maximum. This is the highest you're going to get, the maximum. If it's a minimum, which way is it going to open? Up. It's going to set up a minimum. So when you're looking to find the sum, so say I have 10 plus 100. This gives me 110. When I do the sum, this gives me 1,000. If I did 1 and 109, and I did the product, this gives me 109. So I want to find two numbers that add up to 110 that give me the highest product possible. Now I could stay here and do this for a very long time, or set up an equation for this. So the first thing we need to do is identify your variables. Identify your variables all the time first. So how many variables do we have? 2, because it says find 2 positive real numbers. 2 positive real numbers. So, God bless you. We're going to let x equal the first number. We're going to let y equal the second number. And when we find the sum, what operation do we do? Addition. So we have x plus y equals 110. We have two numbers that add up to 110. Now, we want their product to be at a maximum. So this product, take the product of these two variables. So how do I represent the product of these two variables? X times y. Now, this is the guy I want to graph. I want to graph this guy. And this is going to be my y1. This is going to represent my product. Now I can't put two variables in one equation. So I have to get one of them out of there. So when I graph, I need the x in there. So I have to replace the y in terms of x. So I have one other equation that gives me x and y together, is this guy. Remember when you did your systems of equations, you can eliminate one variable, you can do the addition method, you could do the substitution method. We're going to substitute. We're going to solve this guy for y. Subtract x. So now, if we take this out of here, if I come over to here, and I replace this in here, this will give me one equation with one variable. And that's what we want. So we plug this in. Now, you don't have to distribute this out. You can put this exactly in your calculator. But you see your x squared? Here's your x squared. See it? If I multiplied it out, you get negative x squared plus 110x. See it? So my negative x squared is causing my parabola to open down. So this is going to give me my maximum. So we're going to put this thing in your y1, and we're going to sketch it. So does everybody have a calculator handy? A good way to start that, guys, and you're going to have to work with me here, is go to your window and start your x-min at 0 and start your y-min at 0. I don't want you to do zoom ins and outs. I want you to work the window. Okay, and graph. We see a little bit of a graph coming, right? Now, yes, very little. Now here's a good way to see what numbers you're looking at. Go into your table. You've got your x value, and your y here represents your product. Okay, y1 represents your product. So we're looking for this parabola to go up, 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 reach the top, and turn back down. So we're looking for the highest y1 that we can find. Now your numbers add up to 110, so this could possibly go for a little while. I'm going to make this go as long as it takes because I just want to show you what's happening. So you see your y is still increasing. It's still increasing. Keep an eye on your y. Do this with me, guys, because otherwise you're not going to know how to get through this. Whoops. Did you see it start decreasing? Right there it started to decrease. There's your window. We need the x to go as far as this. Does it have to be exactly that? No. Give it an estimate. So let your x go from 0 to 60. So my x min is 0. My x max is 60. Let's set your y the same way. X max, y max, 60. And let's see if we get a graph. Oh, I'm sorry. Your y max, what was I saying? Your y max. Your y max, where were we? Your y max is over here. It has to be at least as high as this guy. So let's go like 3,200. Just a little bit more so that you can see it turn. This is your x. This is your x. This is your y. So come here and let's make your y max be like 3,200, 3,500, whatever you want to make it, as long as you can see it turn. And my x is not big enough, right? So what do I have to do? Push my x out. Push my x out a little bit more. Now, what did you make your x max? I made my x max 100, just so we could see it turn. You only needed to get to the top, right, to see the parabola turn. I don't really care that it didn't hit the ground, because right now all I care about is my highest number, my product. So you got to go just a little bit to see your parabola turn. And your parabola is only going to exist in quadrant 1, because you're working with an x of positive and a y of positive. So you want to find that maximum number. How do you find your maximum? No, how would you find it on your calculator? Second trace, good. Find your maximum. Number 4. So go to the left. Go to the left. Go to the right. And guess. So this is really, even though it says 54.99999, that's really 55. And that's not your y number, that's your product. So remember these two numbers. X is equal to 55, and your y1 was 3,025. This is your product of your two numbers. This is your x number. Now, you found your x. We need to find the second integer, which we called y. This gets a little confusing because we use the x and the y to be our numbers. If it helps, use two different variables to be those. I like to stick with the x because we use the x over here. And I like it to kind of keep the x there. But just remember that this y1 represents your product. And when you do this in your calculator, this is your product. This is the value of x. So bring this x over here and substitute it in. And y is equal to 55. So here's your answer. two positive numbers that add up to 110, whose product will give me the maximum. That's 3,025 was bigger than 1,000, right? Bigger than 109, right? So it's the maximum product we're looking at. Whatever you're maximizing or minimizing is going to go into your Y1. This is a different concept, okay? You've done systems of equations, you did substitution, you did the addition method. We could do this algebraically if we wanted to. We could set this up algebraically and look for a parabola and find its maximum point, find its turning point, find its vertex if we wanted to. And we could do that, but your calculator does it well. The problem is your windows. You're constantly changing your windows. To change your windows, either estimate it and try it, or go to the table and look for it. Now these values aren't that high that you can't find them. When we go a little higher, I'll show you how you skip over half the numbers. You set your table set, skip over them, and then check it. So let's try a minimum here. Anybody have a question what we did so far? Okay, let's try a minimum. Alright, I'm going to pass that one. And I'm going to go over here. Because the second one is easy. If you can do this one, you can do the second one. So let's skip to the third one. I'll give you the second one for homework. I'll skip to this one. Okay, let's skip to this one. This is different. Okay. The product is 192, and the sum of the first plus 3 times the second is a minimum. Here's our minimum. This is what's going to go into your y equals. If it's a minimum, is your parabola opening up or down? Up, right? So we're opening up. Guys, you really don't have time to talk through this. Product is 192. How many variables do we have, Isaac? I heard you, people around you. How many? 2. Let x equal your first integer. Let y equal your second integer. And the directions on the very top of this said we want 2 positive integers. So again, what quadrant are we working with? 1. Okay, quadrant 1 still. Okay. So how do I say product? So 192 is x times y. Right? That's a piece of information given to us. This sum, this is my y1, because this is what's going in my calculator, of the first one, x, plus 3 times the second one, which is y, is my sum. And that's the guy, that's a minimum. We could change it the other way if you prefer, make y the first variable, x the second variable, but since we set it up this way, I said y was the first, x was the first, y was the second. So the sum of the first, x, plus 3 times the second, 3 times y, gives us our sum. And we want the sum to be at a minimum. We want their product to become 192, but their sum to be at a minimum. And the reason why we're minimizing and maximizing sums and products is because we're going to put this to applications tomorrow or Wednesday. We might want to get an area for like cattle to graze, and we want a maximum area, but we don't want to spend that much on fencing it. So we want the maximum area, but we want the cheapest amount of fencing, which is your perimeter, which is the sum. So we're trying these out now to get a good feel for these, and then we're going to put them into an application. So in your calculator, you're going to put this. What's the problem with putting that? 2 variables. So I got to substitute out. So which one should I substitute out? Y. So come to this guy and solve for y. Divide both sides by 1/9 by x. This is going to substitute this piece right here. The nice part about this is you don't have to figure anything out. Just substitute it in. Remember, this is going to be my sum. X is going to be my number. Y is going to be my sum when I put it in my calculator. Bless you. You don't have to multiply that out. Just plop it in your calculator the very same way. So let me pull up my calculator. I just need to pull my equations. So let's plug this in. You guys need to work this out with me. Alright, let's try it and see if we get the same, if we can use the same graph. Nah. Right? Because what's going to happen with your sum? You want a minimum. So let's set this back, start at 0, and increment by 1. You want your sum to get smaller and smaller and smaller, and then to pick back up again, right? So here's your sum, getting smaller and smaller and smaller. Want to see where it's turning? Look how small it's getting. Getting smaller. Up, it just turned, right? See it from here to here? It just turned. I don't care how exact it is. My calculator will find that when I do my max and min. What you need to do is set your table. Set your window. So my X is going to turn somewhere like 31, 32, 30. Just double it to get the rest of your parabola. This is going to be the lowest I want, not the highest I want. So come to your window, set X to be like about 60, 65. And our max on your Y is not going to be that high. What was it, a couple of hundred? I don't even remember what it was. Just go like 200. Oops, I meant 2,000. All I need to see is this turn. Now, it's kind of not really like a parabola. It's really one of those, one here and one in the other quadrant. But we can see that it has a minimum point. Hang in there, guys. We're almost there. You need to find this minimum. Trace and do your minimum. Either you're doing a maximum or you're doing a minimum. So bring it to the left, far enough to the left. And then far enough to the right. At least like out here. Now, this again, it's rounded, but it's really 24 and 48. So let's see what we have. Don't leave yet. X is 24, and my sum is 48. We need to know the other number. Bring it back in here and substitute it in. 24 times y. Divide both sides by 24, and you get y. So here's your product. This is going to give me 192, and it's going to give me my minimum sum. Okay? And what I want you guys to do tonight is to do numbers 2 and 4. 2 and 4, exactly like the big said. If you didn't pay attention, I suggest you watch the noodles.